Hi, my name is Gordon Lee. I am a product definer and also application manager at Maxim Integrated. Today, I'm going to show you a real-time clock RTC demo. RTC becomes a very important component for many applications, including IoT, handheld devices, medical devices, and many others. Its main function is to keep track of the time. It allows the device to enter deep sleep mode to save battery power while the device is not active. It can also enable the device to do some work according to a preset schedule. The most important specs of an RTC are the sizes, power consumption, and accuracy. The MAX 31343 in this demo is the latest and smallest RTC in the industry with integrated MEMS resonator. The package size is 2.1 mm by 2.3 mm, perfect for small form factor applications. This dimension was impossible to achieve with traditional 32 kHz tuning for crystal. And Maxim is the only major RTC supplier who makes RTC with integrated MEMS resonator. Accuracy of an RTC is very important. As any crystal resonator, MEMS resonator frequency can also be affected by temperature. At extreme temperature like -40 degrees C or 85 degrees C, the frequency error could be over 100 ppm. The MAX 31343 has a built-in temperature compensation circuit to counter this problem. Each MAX 31343 was calibrated in production to acquire the frequency versus temperature characteristic. And then with a built-in temperature sensor, the RTC will know how much it needs to adjust the resonator frequency using a fractional divider. As a result, the MAX 31343 is a 5 ppm accurate RTC over the operating temperature range from -40 to 85 degrees C. On this demo, the MAX 31343 outputs a 1 Hz clock, and the FPGA will compare this signal with a super accurate 10 MHz reference signal generated by a OCXO, which stands for Often Controlled Oscillator, and its accuracy should be less than 0.1 ppm. The FPGA will then calculate the error of the 1 Hz clock signal. On the back side of the board, we have a paltier device right below the MAX 31343. The paltier is used to heat up or cool down the MAX 31343. Its temperature can reach as low as few degrees Celsius to about 100 degrees Celsius. I can use this switch here to select hot or cold operation. Power consumption is also very important. One of the main reasons why a system engineer still use external RTC is because it consumes much less power than the one that is built into the microcontroller. MAX 31343 only consumes typically 940 nanoamp of current when the temperature measurement interval is set to 32 seconds. The demo also has a switch on the FPGA board to enable the temperature compensation circuits. Then we also have a power accumulator IC on the board to measure the current consumption of the RTC. Right now, the temperature compensation is not activated, and temperature is around room temperature. On the screen, the first line shows the error of a single 1 Hz pulse, and the second line shows the average error over 32 pulses. Because the MAX 31343 uses fractional divider to adjust the frequency, each 1 Hz pulse could be slightly different, but over periods of time, the average period is very accurate. The third line shows the current consumption of the RTC. Right now, because the temp sensor is not doing any conversion, the current is around the typical value, 940 nanoamp. The last line shows the temperature readout from the internal temp sensor. The number is not changing right now because I haven't enabled the temperature compensation circuit yet. I'm now going to heat up the RTC and see how it affects the accuracy. The display still shows the room temperature, again because the temperature compensation circuit is not enabled. And very quickly, the average accuracy is getting worse. And that is normal for any RTC without temperature compensation. So let me enable the temperature compensation circuit. And on the display, you can see that the current went up from about 1 microamp to 3 microamps. And the temperature is updated. If the compensation circuit is working, we should expect the average error to come down. In the program, the temperature conversion interval is set to once per second because the temperature change on this demo is very quick. However, in most use cases, temperature changes much slower. So a longer conversion interval can be used and the current consumption are much lower in those cases. Now, the average error is very low. Let me try to cool down the RTC by flipping the switch to the cold setting. You can see the temperature goes down very quickly. And the single cycle error reading also keeps changing. That is because the temperature compensation circuit trying its best to adjust the clock frequency. But if you look at the average error, you will notice it doesn't go beyond 5 ppm spec. And once the temperature settles down, the average error will go down as well. The MAX 31343 has many other features, including battery backup, trickle charger, and power supply auto switch. For more information, please visit maximintegrated.com/max31343. Thank you for watching.